Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In today's video we are going to add a new feature that will display some statistics about the files that are being or have been imported. Previously, we finished the main two panels of the geometry import settings, which at this point offers everything we need in order to import FBX files using different settings. One feature that we are still missing is the ability to tell what the importer is doing after we press the import button. I'd like to see some kind of control that shows the status of any assets that are being imported, as well as whether importing was successful or not. This will apply to all asset types, and therefore I'm going to add a little module that keeps track of what has been done by any of the importers. When a file is being imported, it can result in one or more asset files, which will be represented by an importing item. This is a viewModel class and has a property that will indicate the status of the import operation for this item. It has three states as defined in import status enumeration. An item can be in importing state, successfully imported, or has failed to import. Let's add two read-only properties first. These are the name of the asset being imported and an instance of the asset class that will contain its data. Next, we have the import status, which obviously can change, so it needs to raise a property changed event whenever it does. In order to display a progression value, we need to know what the maximum value is of the progression. For example, if the content file we are importing has 50 meshes, then the progression maximum will be 50. Then we have a progression value, which contains the current value where the importer is with the work it's doing. If we wanted to show the progression in percents, you'd need a normalized value between 0 and 1. Since we are using double precision floating point values, we can't compare them directly, so I'm going to use this extension method which determines if the two values are close enough to be considered equal. Instead of setting these properties directly, I'm going to write a function that will do that for us. I think I forgot to add the progression value. Okay, so here we set the progression maximum and the current progression. We also compute the normalized value and clamp it to a range between 0 and 1. We set the read-only properties in the constructor. That's it pretty much for the importing item. Next, I'll add a class that represents a collection of importing items. I decided to use a single collection for all assets that are being imported and therefore made it a static class. It contains a private list of importing items and exposes the list through a public read-only observable collection. Since this list contains the importing items for all asset types, we'll have to filter it for each tab in Import Settings configuration window. We'll see how this works in a bit later in this video. We also need a lock object because this is a static class that can be accessed by multiple threads. This way we can synchronize modifications to the items collection. We use another private field to hold the item filter. This can be anything and is used by the filtering method to determine if an item should be accepted or rejected when filtering the collection. In this case, I think I'm going to use the asset type as item filter. And there's a method for setting the filter which also refreshes the filtered items list. When a file is sent to any of the importers, we create a corresponding importing item and use the add method here to put it in the list of items. Note that we are locking the collection. In addition, we use the UI thread to modify the collection. Let's also write a remove method, which is identical except for the removing part. Next, I'll add a clear method with a parameter to indicate that only importing items of a specific asset type should be removed. Here we use link extension method to create a local list of items of the specified asset type and remove them one by one. We are also going to need to be able to get an importing item that belongs to an asset. I'll write a method for this too. Actually, I think this should run on the UI thread as well. Now the problem is that whichever thread calls any of the methods of this static class for the first time in application runtime, it will trigger the initialization of this class by calling the static constructor. This means that the collection of items could be created on some other thread than the UI thread. This can lead to random crashes because of thread affinity of the UI elements, which are generated from our observable collection. In order to make sure that this class is always initialized on the UI thread, I'll add a dummy method that we call from a point in code where we know it always runs on the UI thread, and this way we can guarantee that all data structures are created on the same thread. I'm sure there is a more elegant way of doing this, but this is not really a module that's likely to cause design problems down the line if it wasn't designed optimally itself, if that makes sense. Finally, we have the static constructor, which will initialize the data. Here I also write the filter method, which returns true if an item has the same asset type as item filter. I'd say this is all we need, but you know what? Let's add a little extra feature, which is a timer that will start as soon as the importing item is created and will keep running for as long as the item is being imported. For this, I add a dispatcher timer, which is a timer that calls one of our own methods on the UI thread. And I'll use a stopwatch for timekeeping. We can add a string property that contains the total duration of the import operation. By the way, let's make all these properties private set, so no one can interfere from outside. Then we can create an instance of the stopwatch as well as the dispatcher timer in the constructor. Again, we do this on the UI thread. The timer will call the update timer method every 100 milliseconds. Feel free to set this to your liking. It only determines how many times per second we want the UI to update the timer value on a screen. Okay, let me rename this to status, because why not? So in update timer method, if the status is importing and the stopwatch is not yet running, then we start the stopwatch. Then we get the elapsed stopwatch time, format it in a string in the way we want it to be displayed, and set it as the import duration. If the status is not importing, it means that it either succeeded or failed, and we stop both the dispatcher timer and the stopwatch. This is all for the business logic of importing items. Now let's define what it looks like. For this, we can add a new user control and call it Importing Items View, where we can display the list of importing items. I'll put the items in a scroll viewer, since we can have a lot of assets being imported at the same time. Then we add a border that contains an items control, which will display all importing items. We can bind the items source to the list of filtered items after I fix the namespace again. Normally we would bind to a property of the view model. However, this time we only have the static class and it requires a bit more effort in order to bind to its properties. Note that this is not a best practice, since static classes in general aren't supposed to have state nor contain data, but I just wanted to show a different way of doing things. The items control uses a stack panel to display the list of items. Next, we have to define what each item looks like. This is done by setting a data template as the item template of the items control. Within this data template, we can describe exactly what we want to see. Again, feel free to design this to your liking. I'll put a grid in here where we can display the file name that's being imported, its status, progress value, and import duration. Let's add some extra eye candy. For example, I'll add a rectangle with a color that depends on the import status of the item. Actually, let me show you what it really looks like by temporarily putting this outside of the items control so that we can see it being rendered in the designer. So here's our item, and I can set a design time color for the status bar as an example. Let me also set its design time size so we can zoom in and see what it looks like. Next, I'll add a text block which will denote what the asset type is of this item. I'll give it a bit of styling and make it dark gray. As an example, this is how it looks for a texture item. Then we have a stack panel which contains the file name and import duration. It also contains another stack panel for displaying the import status and progress value. The latter is contained in its own stack panel, which is only visible if progression maximum is non-zero. The text is hard to see here because it's black. Hopefully it will pick up the global text block style at runtime. Okay, this is all I'd like to show for each item. Let's put this back in the data template. I would like each item to get a darker background if we put the mouse pointer over it. We can do this using a data template trigger. Actually, I also want the asset type to light up in orange, so here we can say exactly which parts need to react to a trigger. While we are here, I can also add triggers for the color of the status bar and status text for this item, which all depend on the status property. If the status is importing, the text will say importing as well, and it has an orange color. The status bar will also have an orange color. We can repeat this for import status succeeded and failed, which will turn the color to green and red respectively. In case of a failed import, I also want the background of the item to become dark red. Next, we add triggers that set the text of the asset type of the item. For example, the asset type will say animation if an animation item is being imported. We can repeat this for all asset types. That's all for this user control. I'm not sure why I added a progression minimum property here, but we don't need it. The next step is to use this when importing assets. Remember, we need to call the init method at least once in a method that's always called from the UI thread. Import files async is such a method. We could also place this call somewhere at application startup, but I wouldn't like to put this somewhere that's completely unrelated to asset import. When we are about to import an asset, we create an importing item and add it to importing items collection. Let me quickly add an assertion here to make sure that the full path for our asset is correct. At the end, we can set the importing item's status, which is either succeeded or failed. Note that we don't have to set it to importing, since that's the default value for the status property. Now we can add our importing items view to the final panel of import settings configuration control. I guess I made a typo here. We only have 2 columns, so the last column index is 1. Here we have a placeholder for importing items control. We can replace it with the one we just created. Before doing so, I'll add a clear button, which when pressed will remove all items. I'll write the event handler method in a bit. Next, I drop in the importing items view. If we did everything correctly, it should already show items for anything that's being imported. There we go. I imported 2 FBX files and we can see that 2 importing items were successful. We can import more files, which will simply add to this list, even if some items were already imported once before. It's really a shame that using FBX SDK for reading FBX files is slow and can't be multi-threaded. It considerably slows down importing multiple assets, while the CPU is doing pretty much nothing, as you can see here. There are some open source alternatives though, which read data from FBX files without using Autodesk's marvelous SDK. So it could be an interesting exercise to try and use one of those. Anyway, it looks like it's working. Now let's write the method for clearing items. Here we only want to clear items that could be imported by the geometry importer. These are the animation, material, mesh, and skeleton asset types. This should take care of removing items. Finally, we'd like to only display items that belong to the currently selected tab. So if we select Geometry tab, only importing items for meshes should be visible. This is why we set the tag property for each tab here. We can use this to set the item filter whenever the tab selection changes. Here we get the selected tab and its tag and use it to set the item filter for importing items collection. Now we can clear the list of items. And this is all I wanted to do in this video. In the next video, we are going to make the progression indicator work with the geometry importer. We are also going to add a feature that allows the user to coalesce meshes that would otherwise be saved to separate asset files. As always, thank you for joining me and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering.